a CD is a long track, and the laser hits the CD, and if it's shiny, it comes back, and that might be like a 0. But if it's a place that got burned out, that little pit, then the laser doesn't bounce back, and that's like a 0. And it goes 0, 0, 1, 1, 1, 1, 1, 1, 0, 0, 0, 1, 1, 1. And that might be one note. And there might be another track that says how loud to play it. And you said, that can't be what that is. That is what a CD is. And every time you take a picture with your camera, what are you doing? You're taking real light and changing it into a signal that's a series of 1s and 0s. And that's what I was trying to get to you last year when I was trying to show you. It's a powerful idea. Okay, so everybody ready? Let's go ahead, and I think I gave everybody this handout sheet on Power of the 10. And again, because it's the third time, you say to yourself, I'm a big boy and girl now, and what I'm going to do is I'm going to make sure I know it. And so I'm going to help you a little bit, and then we're going to go, again, we're going to go a little bit faster than we did, but we're going to try to get that down. Okay. All right, now again, what we'll do is, and I'm glad you said, hey, Owen, thanks for telling me that, because they're not going to have a physics student, AP physics student, not know metric system, Power of the 10. This is related to scientific notation. It's related to so many things. Okay, so here we go. What if you had a blank one of these? If you had a blank one of these, how many would you be able to fill in already? So what we're going to do is we're going to go to a blank one. So I want you to go to the next page, flip it over to here. All right, we'll go around the room. I'm sorry, am I off?
No, I just don't think we have one of
Oh,
those.
I did not give these to you?
No.
Ah, my fault. My fault. Okay, so I printed them. Hey, thank you very much. I printed them, but I didn't give it to you. All right, here we go. Whenever you get this, turn to the second page. Turn to the second page, and we're going to try it without looking on the first page. So we'll go, Clayton, you start out, and then we'll go Marie, and just go right around the room and say, here's one I do remember. Okay? And so which one do you want to do? All right, real quiet.
10 to the negative first.
Okay, wait a minute. All right, 10 to the negative first. What do you remember about 10 to the negative first?
It's a little c and it's decimal.
Okay, so 10 to the minus first, which is 1/10. The abbreviation is little d, and you said deci, right?
Yes.
All right, so remember that one, and everybody got that down maybe? Is everybody okay on that one? Okay, all right, Marie, wait, pick any one.
10 to the negative 2.
Okay.
Little c and centi.
And so you don't have to study these, do you? Because you know that one, right? Give me one you know. You're pretty sure you know it. And if not, I'm okay.
Kilo.
To the net.
I thought you said asking.
No, we're going around.
down.
We're just kind of going around. Okay.
Disrespect.
Okay. Shh.
10 to the negative 3 is milli.
Okay. Abbreviation.
M.
And little m, right?
Right.
Now, Lindsay, would you say that you don't have to study that? You know that one, right?
Yeah.
Okay, good. Next. Rollins.
Oh.
We're kind of going
Is it just anyone or?
anyone you want.
Oh, okay. 10 to the first.
10 to the third?
Uh,
First?
Sure, third. Is
Third? Okay.
kilo.
What is it?
Kilo.
And what's the abbreviation?
K.
And it's a small k, isn't it? So kilo. And that means 1,000. All right, Owen.
10 to the 6th is M, and that's 10 for
Little m or big M?
big M,
And it had to be big M because we already used little m over here, didn't we? And what's this stand for?
mega,
Okay, another one?
Offer 10 to the power 3.
10 squared?
10 squared
Okay.
is hecto,
Okay, abbreviation.
small h.
And I want you to turn that over so I don't want you to look at it. How about
Oh,
that?
sorry.
What I'm trying to say is, how many of these do you already know and you really don't have to study them, okay? And when you hear somebody else say it, oh yeah, I should remember that one. All right, Jeff?
Z10 to the 9th.
Okay,
Gig,
okay.
and it's just a capital G.
Yeah, capital G. So that's a billion, isn't it? Okay. Now, by the way, I ran out of space here, but I'll go ahead and put 10 to the 12th here. And if somebody wants to do that one, they can. And I'll also go down here to, I'll do 10 to the minus 12th down here, and if somebody wants to do that one. All right, back up to you, Clayton. They're getting harder now.
10 to the negative 6.
Okay,
Then micro.
okay.
Is it mu or
Right, so we already used a capital M, we use a small m, so now we go to another alphabet, and we use the mu, and the mu, as a prefix, you do put a hyphen after it, means it's a prefix, something has to come after that. Very good, that means 1/1,000,000th of anything. All right, next, Marie.
10 to the 1 is deca, and it's big D.
Is it what kind of D?
Big.
Now, some books, they used to say DEKA, and some do DECA, and I'm not a Latin or Greek person, but one of those, which one does Latin or Greek not have? Who doesn't have K? Is anybody a Latin person here? Nobody's taking Latin?
What? There.
Does Latin have the C or the K? Is it Greek that has a K? Okay, so you might read a book that says DEKA or DECA, but anyway, the abbreviation though, interesting, you don't use any capitals till you get to million. So it has to be small letter. What is it again?
Oh, is it DA?
Yeah. Now, when they first started this, and they brought this over to the United States, I can show you a book. They said it was, they wanted to have DC, and they changed that. They said that's not very good. They went to DA. All right, next.
10 to the negative 9
All right.
is nano.
Okay. And so that's down here. And nano, what's the abbreviation?
I don't know.
And it's lucky it's a small n. So the ones that start with the letter, I like that. All right, Rollins.
10,
And if you say, I don't remember anymore,
I think, 10 to the 12 is Tera.
all right. And what kind of abbreviation is that?
It's a capital T.
I remember, when I first started teaching, I've told you this story before, and you think, man, you are old. But I remember the first person in my neighborhood who had the first personal home computer. And it was it was really rough, but the first one that you have a home computer, that was just unbelievable. And so it was like a 64K. 64K. I want you to think about that.
They have color.
64K. No.
Oh,
Now, it's so small of a memory. You know what K means, right? 1,000? Okay. Do you know what your computer now has? You know what your phone has? You know what your phone, every picture you take, you know what that is?
is it like,
It's like
Each picture is what? Isn't it like 1.5
kilobyte?
megabyte? Isn't it mega?
Less than 10 megabytes, or like it can be even like 8 megabytes.
No worries.
You can have a picture, depending on what quality. You could have a 1 or 5 megabyte picture, just one picture. And this was what? 64 what? K. Now, it was amazing that there was a thing you could actually bring home and act like a computer, but they didn't have space on the computer for a lot of programs. So they had a cassette. A cassette had the programs on it. You had to load the cassette. But then my brother-in-law, he got a, not 64, they came out with 128 after that. These are all powers of 2, by the way, binary. And then the one after that, he got a 256. Whoa! You have a 256K. And then I clearly remember when they had the 1 megabyte. Whoa! 1 megabyte. Who in this room has the computer with the biggest amount of storage, or
Probably
what do you have?
2 terabytes.
How much?
2 terabytes.
Wow. That would blow people. Well, you go back 20 years ago, they'd say, no way. 20 terabyte. Unreal. So anyway, these actually do come into play. Let's go on down here, and we do need one more right down here. 10 to the minus 12, and you know that one?
I know minus 12.
Okay.
It's pico.
Okay, and abbreviation?
Oh, is it P? Is it
Yeah, yeah. One thing, we have one unit, a chapter on nuclear chemistry, and when they measure radiation, some things are so poisonous, they're so poisonous, that you have to be able to measure even tiny amounts of them. And when you start hearing about picocuries, you have to measure something at 1 trillionth part per trillion, right? If there's a trillion pieces of air and only one of them is that radioactive material, you have to be able to measure in picocuries. So when you get in the science world, you're going to have big numbers and you're going to have small numbers. You get that? And all of these, what's neat, it's a pattern. It's a pattern. So now, let's do a little bit of review. We're going a little faster, aren't we? Is that okay? And by the way, I want to show you a couple of things before I leave this page. Let's go back to this page. So you did a good job coming up with these. I do want to mention a couple more. Since you guys are in a new generation, you probably should learn this one and this one. Okay? So not 10 to the 12th, but what's bigger than 10 to the 12th by 3 powers of 10? And I'm surprised somebody didn't say they had you have a terabyte computer? Have you had a petabyte computer? Anybody hear of petabyte? You're going to hear about that very soon. Okay, very soon you'll hear about petabyte. So that's 10 to the 15th, and that is unbelievable. Okay, now this is incredibly small. It's less than a trillion. This 3 powers of 10 less than a trillion, and it's called femto. I do believe they'll show up if you guys stay in science. I think you'll see both of those. I probably won't. If I put that on the test, it'd be extra credit. I wouldn't expect you to happen to know those, but if you want to do extra credit, you can. The other thing that we noticed is that, and I did this again, especially in 11th grade, these are all related to some power of 10. So when you hear mega, you have to start saying to yourself, that's a million. And a million is 10 to the 6th. Now, I think you should learn it this way. Mega is a million. What's 1 millionth? What's a millionth? And the good news is if a million's 10 to the 6th, what's a millionth? 10 to the what? Negative 6. That makes it easy. See that? If a trillion is 10 to the 12th, then what's a trillionth? 10 to the negative 12. I like that. So if 10 to the 3rd is 1,000, what's 10 to the minus 3rd? See that? And so that's what I would do. I learned them as pairs. That's easy. Now, the next thing we got to be careful about is when you write them out. I know you learned this long ago, maybe in 7th grade math, that 10 to the 3rd means 10 times 10 times 10. Isn't that right? Didn't they teach that to you a long, long time ago? So if I wrote that number out, 10 to the 3rd really does have 3 zeros after the 1, all right? In between the decimal and the 1. And a million is 6. It has 6 zeros. A billion has 9 zeros. A trillion has 12. See? Yes? If you're interested in this, is not really scientific, but did you know what's really weird? This is really weird. See this number here? We call that a billion. But how many sets of 3 do you see? How many sets of 3 zeros do you see?
9.
No, how many sets?
Oh.
That should be called trillion. But we call it billion. And you know, at one time, England, they called that trillion. And we called it billion. And at that time, we were more influential in the money world, and they had to change it. It doesn't make sense. But what you could say is how many thousands there are. There's that could be billion if you're talking about how many thousands there are, but that should be called trillion, but they don't do that. Just want to let you know. That has nothing to do with this chapter. All right, now, the other thing that I wanted to show you is down here, and every good science student is going to know these two, okay? You're going to take probably biology and chemistry, and so the two that are not prefixes, okay? The ones that are not, I know, I didn't finish my story. If a million has 6 zeros, how do you write a millionth? Decimal point? Only 5 zeros. Get that? So the 1 is the 6th place, but there's only 5 zeros in it, right? And that's something a more advanced student would know automatically. If I say write out the number 1 billionth, you say, well, a billion has 9 zeros. A billionth would only have what? It would be a decimal point what? 8 zeros and a 1. Okay? Okay, next. There are two things on here that are not prefixes. Angstrom and micron. Now, in the biological world, they were looking at things under the microscope. And if you look at some of the older books, they'll say 55 micrometers, and if they had the symbol, and back then typewriters didn't like that mu symbol. They hated that. So they write out micrometers. See that? And now we don't have to worry about that. But so 55 micrometers, but they're humans. And I believe humans said, do I have to keep writing out micrometers? It takes a long time to say that. How about deoxyribonucleic acid? Oh, do I have to keep saying that? Why don't we say DNA? Yeah. We're going to do that because they're humans. You see that? And so whether you like it or not, what they did is they stole this symbol here, the micrometer, and they turned it into just a plain old mu. And the mu it's not a prefix now. You see that? I can put this, anything you want to go after it. Mu cars. That's a millionth of a car. But if I just see the mu symbol by itself, it's not a prefix. And it's a distance unit. And what does it mean? A micron is 10 to the minus 6 meters. It is a micrometer. You get it? So the mu by itself is something you're going to hear. If you go into any kind of biology or even chemistry, you're going to see the micron used. Micron a little bit more in the biological areas, but what if you get down to the atomic size? They probably said, I wish the atoms were the size of a nanometer. That would have been easy. No, they're smaller than that. So they made their own, and they made this thing called angstrom. And so what is an angstrom? And I've seen a capital A, I've seen a little a with a little, what do they call that? I'm not a Swedish person, but what do they call it, a little symbol? Umfla? Anybody? They have a name for that little circle. But anyway, if I was in Sweden, I could ask them, they'd tell me. Anyway, this right here is a distance unit. It's 10 to the minus 10 meters. And so angstrom is not a prefix. It's a distance unit also. And it's a 10 billionth of a meter. Are you okay with this? That's probably the third time you heard that story, so I think it should be sinking in right now. Does everybody know what a micron and angstrom is? Please don't go to college and not know these. I want you to know them. I want you to know these. And when they say something about angstroms and the person next to you says, how much is that? You said, what's the matter with you? You said, what's the matter with you? What's the matter with you? Okay? Or you're in biology class and they said, well, this cell is 80 microns by 50 microns. Somebody said, is that a lot? No. It's a millionth of a meter. It's a millionth of a meter. All right, let's go to this page. Now, let's do something. Again, I'm working at a good pace. We're going at a good pace. All right, here we go. Now, here's what I would do in 10th grade. In the 10th grade, I would say, because these are related by powers of 10, if you want to convert from one metric unit to another, you don't change the numbers, you just move the decimal. See that? And that works. That works well. Just like our number system is based on powers of 10, the metric system was based on something. He said, why don't we base on something that every human knows? And they knew powers of 10 for the number system. So the metric system is based on that. That was smart. That was really smart. That was the French Academy of Sciences, wasn't it? That was smart. Now the whole world uses the metric system. Now, it doesn't work. What I'm going to show you here, it doesn't work with the English system. It won't work with feet and inches. It won't work. has to be based on powers of 10. So let me show you how I do it in the 10th grade, and then I'll make you big boys and girls, and we'll say we're going to use the big boy and girl method from now on. And I would have said here, what are you going from? I'm going from milli prefix to kilo. And this is very concrete, but you might like it. You say, I feel concrete today. Put your finger on milli and go toward kilo. My finger moved 1 to the left, 2, 3, 4, 5, 6. I saw my finger go 6 steps to the left. Now, again, this is a concrete way of doing it. I'll show you a more advanced way. All right, here we go. I take this number and I move. And by the way, some of you said, ooh, I don't see a decimal in that number. Give me a break. If I give you that much money, do you think you could find a decimal? Yes, you would, couldn't you? I'm going to give you this much money. Oh, God. You're going to give me over $1 million. You know where the decimal is, don't you? Now, move the decimal to the left 6 places. 1, 2, 3, 4, 5, 6. So in the 10th grade, I would have said, simply put this down, and you're done. You changed millimeters to kilometers. Got it? Now, if you still want to do I call it the underhand serve. If you still want to do that, you're going to get the problem right. You're not going to miss the problem if you want to do it that way. You get it? But you're not going to be that step above what I want you to be. So let's go to the next way of doing this problem, okay? Let's go to the next level. Got it? Now, millimeters are small, kilometers are big, right? Now, think about this. If I had a lot of small things, would that be more big things?
No.
If I had a lot of pennies, would that be a lot of $10 bills? No. So you know if I convert small things into big, the number has to shrink, doesn't it? It's not going to be a million over here. So then you go to yourself and do this. I know that milli is 10 to the what? And again, I'm showing you 3 methods. You got it? 3 methods. You decide which one you like. Milli is 10 to the minus 3, right? I'm going from 10 to the minus 3 to 10 to the plus 3. In my mind, 10 to the minus 3, 10 to the plus 3. I know I got to move that decimal 6 places. Now, if you don't want to worry about, if you use this chart, your finger went left, and it's simple. You move it left. But let's go a little bit more advanced. This number has got to get smaller. How many powers of 10 smaller? How many powers of 10 separate these? Everybody.
6.
So make it smaller by 6 powers of 10. Okay. 1, 2, 3, 4, 5, 6. I did it. Now, you ready for the third method? The third method is the one I want you to do. If you were on a test or a quiz and you said, I'm not feeling that great, you just use the underhand serve. You get it? You just do the thing like that. But let me show you what I think you should be able to do. You're not going to have a scientist write that number like that anyway. They're going to do this. You see that? Now, if you do the underhand serve method, here's what you have to do. Take it out of scientific notation and then move it. And you see? So what we're going to do is we're going to think, okay? Here's my original number, and you said this second number has to be smaller, right? If you change little guys into big guys, it got to be smaller, right? How many powers of 10 smaller do I need to make it? How many? 6. Ready? Make this number 6 powers of 10 smaller. Is that the answer? Okay, let's do another one. We're going to do it 3 ways, and then you say, I don't have to do the underhand serve anymore. Okay? Underhand serve. What's micron? Where am I?
Negative
10 to the what?
Negative 6.
Okay, and where are you going?
Negative 9. 10 to the negative 9.
Okay, is that right? Now, if I do the underhand serve, I have to go like this. Here's 10 to the minus 6, and here's 10 to the minus 9. My finger goes 1, 2, 3 to the right. So if I move the decimal 3 to the right, I will get this question right. So here's 880, right? You know where the decimal is 880, right? If I give you $880, you know. Now move it, the decimal, 3 to the right. All right, what do you think? Is that pretty easy? Is it getting easier than it was in 10th grade? Now, let's go a little more advanced. Ready? When you say micron, you're at 10 to the minus 6, right? And here, oh, by the way, which one is this smaller or which one's bigger? Which one's smaller? I've got a certain number of what? What are microns compared to these guys? They're big. I got a bunch of dollar bills. How many pennies will that be? A bigger number than I had or a smaller number?
Bigger.
Like $5 is how many pennies? Less than 5? No, way more than 5. You get it? So in my head, I know the number's got to get bigger. And how many powers of 10 bigger is it going to get? How many powers of 10 separate these? 3. Make it 3 powers of 10 bigger. Okay? 1, 2, 3. Now, let's do it another way. Ready? Let's put this in scientific notation. 8.8 times 10 to the second. Now, ready? You said you have to make it 3 powers of 10 bigger. Make this number 3 powers of 10 bigger. What do you get? Make this number 3 powers of 10 bigger. Don't even look at that. Make this number 3 powers of 10 bigger. What would you get? Uh-oh. What? How do you do on that one? Make this number 3 powers of 10 bigger. What would it be? Lindsay. Make this number 3 powers of 10 bigger. Hey, man, that's all right.
8,000.
Okay, let's try it again. I'm going to keep it in scientific notation. Rollins, make this number 3 powers of 10 bigger. I'll give you a hint. Don't look at this part. What?
It's 10 to 8.80 times 10 to the fifth.
To the what?
Fifth.
The fifth. Is that what you said?
Yep.
So if I make this number 3 powers of 10 bigger, it becomes 10 to the fifth, doesn't it? Now, but you said the answer was this. Hey, change that in the scientific notation. What do you get? 8.8 times 10 to the 1, 2, 3, 4. Oh. Yes? Now, I'm okay if you want to use the underhand serve, but see what you had to do? You'd have to, what if I put it in the scientific notation? You have to take it out of scientific notation and then move your finger, and then you have to put it back in the scientific notation. You get that? And that's why I'm asking to be a little more advanced. And that's why you're going to have to practice. You have to practice a little bit because you have to trust it. You guys trust the finger method, don't you? Pretty concrete, isn't it? I want you to start trusting the other one. All right, let's try this one, and let's go ahead and do it the concrete way and see what you get. Everybody do it. Do number 3 and see what you get. So just do it the old concrete way. And I'm going from deci to micro. Okay, right here, ready? Deci to micro. My finger went 1 to the right, 2 to the right, 3, 4, 5. I have to move my finger, I have to move the decimal 5 to the right. So let's take the original number. Now move the decimal 5 to the right. 1, 2, 3, 4, 5. Did everybody get 2,400? So you know that's going to go over the net, isn't it? You know that you can get this right, can't you? Now, I want you to pretend now we're going to do the next level. Which one's bigger? Are these big guys compared to that, or are these little guys?
Big guys.
So it's like dollar bills, right?
Yeah.
These are dollar bills, and these are like pennies. If I want to change dollar bills into pennies, the number is going to get bigger, isn't it? Now, how many powers of 10 bigger? Deci is 10 to the what? -1, and what's micro?
Oh, wait. Oh.
10 negative 6.
Ah, so how many powers of 10?
Oh, I thought it was...
-1 and -6. How many powers of 10? 5, isn't it? You got to make this number 5 powers of 10 bigger. So how do you make it bigger? Oh, try both ways. One of them will make the number bigger, won't it? And you get the right answer. Now, third level. The third level, the one I really like you to be at, is pretend that this is in scientific notation. 2.4 times 10 to the second. How many powers of 10 bigger do you need to get it, you said? You said it had to get bigger. The number has to get bigger. How many powers of 10 bigger? 5. make this, Jeff, you can do it. Make this number 5 powers of 10 bigger. I'll give you a hint. Don't mess with the first part. Make that 5 powers of 10 bigger.
Is that a -2?
It's at -2, yes. Now make it 5 powers of 10 bigger.
Okay, so it's 10 to the 30.
Yes, yes, yes. Now, I said the answer was 2,400.
Yes.
Change that into scientific notation. What do you get? 2.4
Times 10 to the 30.
times 10 to the third. Ah, see? The more of these you do, you start trusting a little bit. I'm okay if the only way you can do it there, but you're letting yourself down a little bit. If this is the third year you hear this, you should be a little more advanced. And the people that, there are a lot of people that they would be in college, and a lot of teachers spend very little time on this, very little. And then I had kids come back from college all the time, and they tell me this. They tell me things like this. And they're very comfortable. Any metric unit, they're comfortable. Scientific notation, comfortable. All right, let's do a few more, and then we'll, let's go over here. How about, oh, okay. Actually, today, advisor comes, this class ends at 2:05. Okay, yeah, this class ends at 2:05.
Yeah, it starts at 2:05.
This ends at 2:05, and advisory starts at 2:05. So if I'm gonna cut anybody a little bit short, it's gonna be advisory. So I'm gonna let you out at 2:05 probably. Okay. All right, here we go. I want you to try this one. Let's try this. Try this one. Any way you want. Try it any way you want. How about this right here, number 7? Okay. And you can try it the concrete way. I'm okay with that. Mega Millions. All right, what do you think? Are you in the concrete way?
I
Okay.
did concrete way.
How many, what direction did your finger move and how many steps?
It went to the left 3 times.
All right, 3 to the left. So I take the number 2.21 and I move the decimal 3 to the left. 1, 2, 3. And so you would say the answer is 0.00221. Everybody get that? Okay, now let's do another way. Are these bigger or what? Which one's bigger? Small to big? So if I had a lot of pennies, let's say 100 pennies, is it going to be a number bigger than $100? Oh. Oh.
Good job, Rollins.
Okay, there you go. Thank you. All right, one more time. So these are bigger, these are smaller than that. And so if I'm changing pennies into dollars, the number is going to get smaller. And 100 pennies is not going to be more than $100. It's going to be smaller than 100. So I know the number's got to get smaller by how many powers of 10? 3. Make this number smaller by 3 powers of 10. Okay, I did it. Now, what is this number in scientific notation? Isn't that it? Isn't that it? Make that smaller by 3 powers of 10. And let me call on Clayton.
2.21 times 10 to the -3.
That's it. And let's put this number in scientific notation. Ready? It's 2.21 times 10 to the what? Ooh, it works. Will you at least be willing to say, I have a backup plan. I can change any metric to any metric with a backup plan, but I should be able to be a little more advanced in doing it. And I'll show you one that you would have a little trouble with, and this might be the last one we do, all right? You did not like, in 10th grade, you did not like this at all. You didn't like this in 11th grade. 1 billion micromoles equals how many millimoles? What do you think? How in the world do you do this? Which method's going to work for you? Are you going to write the number 1 billion out That'll take a while, won't it? What could you write? Okay, isn't that a billion? Now, micro is what? 10 to the minus 6, and what's milli? So, what are you going from? Are you trying to change a lot of little things into lesser big things, or do you have a lot of big things? What do you think?
You're trying to turn lesser one into a.
Yeah, these are smaller than that, right? So 100 pennies is going to be only $1. So we have to make it smaller by how many powers of 10? 3. Make this number smaller by 3 powers of 10, and let me call on Marie.
1 times 10 to the 6.
Excellent. What do you think? Would you at least be willing to be a little more fluid and say, I can actually maybe understand this very well? All right. What I want you to do, what I'd like you to do is, we might review this a little bit tomorrow, but we're mainly going to go quickly through scientific notation. I'll show you how to do it without making a mistake ever. And then we'll do, okay, we'll do some more things. So, all right, see you tomorrow. Thank you.